This video is recorded to help my students to understand how to do Project 7, which asks students to implement several functions that are related to array. The first function is fill array that will fill an array with integer array whose actual size is greater than or equal to this argument size. So post condition is ARR0, which is the first element of array, up to the ARR size minus 1. Totally size number of elements in the array are filled up from the keyboard. Second function is print array. So this again, the ARR has actual size that is greater than or equal to the size, and ARR0 to ARR size minus 1 are printed out to the screen with 5 elements per line. Then the next function is linear search. Linear search, you give me an array, give me the array size, and give me a key you wanted to search. So then I will search through this array. The index of first occurrence of the key in the array is returned. If the key cannot be found in array, then it will return -1. This linear search. You can find the linear search algorithm or implementation in your textbook. The next is select sort. This function, if you give me array and give me the array size, then after the function is called, then the array will be sorted, which means the array elements will be rearranged from the least to the largest according to select sort algorithm. The select sort algorithm also can be found in your textbook and is implemented in your textbook. The next is insert sort, have the same precondition and postcondition as select sort, but this function will implement by using insert sort algorithm. The last one is a bubble sort. This bubble sort, I believe you can find in your textbook access part, or you can search online easily to find this algorithm and its implementation. Finally, you need to have a menu for user to choose. You need to implement all those functions. The main function is given. After you read those functions precondition and postcondition, you should be able to understand what this main function is doing. Let's have a quick look at the main function. First, we declare an integer variable choice. This variable will be used in the switch statement, case 1, 2, 3, 4. Those cases are the choice to match all these cases. Now, another is integer array with size 9. Since I just want to test, I don't want to use array too large, since I want to fill up those array from the keyboard. So I need to choose 9. Now, let's say first display the menu, then ask a user enter his choice. After getting the user's choice from the keyboard, you switch the choice. If the user chooses 1, let's say what is option 1 in the menu. Option 1 in the menu, he first will fill up an array from the keyboard with 9 elements, then print out enter the key you want to search. So the case 1, which is the menu option 1, actually will test linear search function. Now then ask a user enter key. After user enter key, he get the key from the keyboard, then he will call linear search function. Remember, linear search function, you give him an array, give him an array size, then give his key wanted to search. Then this function will return an integer, which is the index of the first occurrence of the key in the array. If the key is not show up in this array, then -1 will be returned. So if the return value is -1, then you will print out the key is not in the array. Otherwise, you will print out the key is number index plus 1 elements in array y index plus 1. If index is 0, that means it is the number 1 element in the array, which is the first element in the array, because array index starts from 0. Okay, so this so you know the menu option 1 should be test the linear search function. Now let's say the case 2, which means your menu option 2. First you fill up array, then you use select sort algorithm to sort this array. Then you print out a message after sort the array is, then you call print array function, print out this array. Now you can check if the array print out is sorted or not. If it's sorted, which means your selected sort algorithm implementation is correct. So same like the option 2 in the menu is test select sort algorithm. The option 3 in the menu is test insert sort algorithm. Then the option 4 in the menu is test bubble sort algorithm. Option 5, user want to quit this program. Then the default, which means is not option 1, 2, 3, 4, 5. That means user type a run choice. Then you need to ask a user to choose from the menu again. Okay? Every time I will clear the screen, that means every time the program will display the menu from a new screen. Then this loop keep going until the choose equal 5. Another choose not equal 5, which means it's not the quit case. You will keep doing so. So this actually is a program show you us again how to write a program, use the menu, so you can manually test all those functions you wanted to write. Now, after you understand what this program do, you know you need to implement those following functions. So I write down all those functions. This menu function I will not type again because I notice all the students can type the menu function. You see, you just need to remember your menu option 1 is test linear search, menu option 2 is test select sort, then test insert sort, test bubble sort, then quit. So this menu function easy to implement is a void function, just have whole bunch cout statement. Okay. Now most functions are void function, but there is one function called linear search function. Before you implement this function, you notice there is an error message here. If you look at this, they say the control reaches end of a line void function. This error message basically says since it's a line void function, you're supposed to have a return statement. So you don't have a return statement, so he catch the error. Now, how do you fix this? You can just say, since you want to return an integer, so I can temporarily say just return -1. How about that? Now, this error message will gone, I believe, right? You see the error message will gone. Now, notice this kind of implementation is not correct, but will allow you be able to compile your program. So this kind of implementation, we have a name there called stable. In your test 2, there is a question, implement a stable version of a function. The stable version is very simple. If this function return an integer, you just need one statement, return any integer. This is stable version. This stable version is not a correct implementation of the function, but it will make this function be able to compile and put this function in the program will be able to let your program at least run. Might not run with a good right result, but it will allow the program be able to run. So that is a stable version. Now, after you put this stable version, you see there is no more error. So you know your program has a good structure. Now, let us begin to implement these functions. First, you need to say which function you want to implement first. Well, it's very simple to say I first will implement a fill array first. I will be able to fill up array. Then I should be able to print out array, right? Because if I cannot fill up array, I cannot get an input. I cannot print out array, I cannot see the output. So I need to implement these two functions first. Let us try this fill array function. So you want to fill up array from ARR0 to ARR size -1. So you might want to give user a hint, say like enter how many integers. So I print out cout enter size so many integers. Okay. Now since you want to enter so many integers, so what I do, I can use a for loop for integer I equals 0, I less than size, I plus plus, right? Every time I will see in an integer, this integer will assign to ARRI. Remember, if you read the book says array element integer array, every element can be treated as a integer variable. So ARRI is the ith element, index I element in the array. So this, since array type is integer, so this can be treated as integer variable. So I can read an integer from the keyboard, assign to ARRI. Okay, this is how you fill up the array. Now, if I want to print out the array, again, I will use the for loop. For example, integer I from 0. This for loop basically steps through the array I less than size I plus plus. So now every time I will print out cout ARRI. After print out, I might print out, for example, I will print out a space, or I print out a type of space. Okay, it's up to your choice. Now, but I want to print out a new line every time after I print out 5 elements. So I will say if I percent, for example, 5 equal 4. Now pay attention, I percent 5 equal 4. That means this I, when I equal 4, or I equal 9, or I equal 14, or I equal 19, right? Since your I start from 0, 0 to 4 is 5 element, 5 to 9, another 5 element, 5, 6, 7, 8, 9, right? Then from 10 to 14, another 5 element, so on. Every 5 element, you will print out a new line. So this will print out your array to every 5 element in one array, in one of the array in one line. Okay. Now you actually can begin to test your program. Notice your select sort function, you did not implement it. So since you did not implement it, which means when you call this function, nothing will be done. That means your array will not be sorted. However, your program still can be able to compile and run. So let us run the program. Then I try to test select sort. I try to test the select sort. First step, I fill up the array. Then I call select sort. We didn't implement select sort yet, so nothing done. Then print out after sort, I print out the array. So I actually will print out the array as it is not the sorted. So even I cannot test the select sort, but at least if I use option 2, I can test the fill up array, and I can test the print up array. Okay, let us try to run this program now. Hopefully we didn't make any mistake. No, we didn't. So let us make a choice. So for example, I choose option 2. Then he asked me enter 9 integers. Let us enter 1, 9, 2, 8, 3, 4, 6, 7, 5. Is that 9? Yeah. Now he said the array element is 1, 9, 2, 8, 3, 4, 6, 7, 5. Yes, so our 5 element in one row, right? Now we know what we did is correct. The only thing is it seems like our menu try to display again. First of all, is not a clear screen, because this clear screen only work for the window. It's not for this Mac computer. Second, after I print out those, I print out the menu again. I suppose to put my cursor to a new line, so my menu will print out lesser. So what I will do, I will go here, change. After that, you can either put here, print out another new line. So your function after print out array, print out another new line. Okay. Now, every time you make a change, please rerun the program. Oh, I need to stop the previous run first. Then let's do 2 again. Now we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you say, oh, run choice. So sorry, I didn't make a choice first. So I will say choose option 2. That enter 9, enter G 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now you say, okay, we'll print out 1, 2, 3, 4, 5, 6, 7, 8, and 9. Print out lastly. Now the pause command not found, clear screen command not found because I use Mac computer. When I prepare this, I prepare it for the window. So in that case, in Mac computer, if you use Mac computer, you comment this away. So then the 2 error message will not be there. After you comment away, let us choose quit. 5. So now quit. Now after comment this away, you need to rerun the project. Every time you make a change, rerun to test, make sure your project okay. Your change did not cause any errors. So let us do 2 again. So this time 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? Now you say everything is less than the lead. Okay? Then I quit. Okay. So we finish fill up array and print array. Now let us do the linear search. Linear search is you will step through the array to search the key. If you find the key, you return the index of the element that matches the key. So again, step through array, you always use a for loop. Array index start from 0, so for I equals 0, I less than size, I plus plus. Then you say if ARR I equal the key, that means you find a match. Then what you will do? You will return I. Okay? You will return the index. So, well, return statement will finish the function call. So every time you find that you will return I, which is the index of the element that matches the key. Since you started from the first element with index 0, so it will return the first match of the first element and match the key in the array. Okay, so let us try this again. So now I can, every time you implement one function, you run the program to test it. This time I can test the linear search. So I type option 1, enter 9 integers. So I do, for example, 1, 9, 8, 4, 2, 5, 3, 7, 6. Okay, this is 9 integer. Then I type enter key. Now enter any key you want to search. For example, I want to search 2. Now notice that 2 is at the index 0, 1, 2, 3, 4. 2, his index is 4. So you know if return value is 4, then you know your linear search seems like right. So I hit enter key. He said the key 2 is number 5 element in array. That's it, 1, 2, 3, 4, 5, right? Number 5 element in array. Well, and his index is 4 because your index start from 0. Index 0 is number 1 element in the array, the first element in the array. Okay, so it seems like our linear search is okay. But when you test a function, you need to test all cases. What that mean? Here say if key is not found, -1 is returned. So you need to make a case that key is not found. So let us test again. So enter 9 integers 1, 9, 3, 2, 5, 7, 4, 6, 8. This 9 integer. Now suppose I want to search 10. We know 10 is not in this array. So we'll say the key 10 is not in the array. Why? If you look back our program, to linear search, the index will be -1 because our linear search say if you cannot find it, you will return -1. Where it say that? Let me finish this test program first. I type option 5 to quit. You look at here. What does this for loop do? This for loop steps through the array from the element 0 to element size -1. If I find a match, I return index of that element that matches the key. Now, if this for loop finished, I still didn't return which means I did not find any match. Then finally I return -1. Exactly fulfill the post condition. When you did not find k in the array, you return -1. Okay, so we finish linear search successfully. Now we have 3 functions left: select sort, insert sort, bubble sort. I will only pick one to implement it. So let us implement the select sort. Okay. Now, what is the select sort algorithm? Select sort. So the idea is every time you select the smallest element, put into its final position. What that mean? First, you select the smallest element in the whole array, put it in the first position. Then, for the rest of now the first position is sorted because he is the smallest element in the array. Then start from position 2 to the end of array. You select the smallest element, then you put it in the position 2. Now the position 2 is also in the sorted position. Then you start from position 3. You pick up the smallest element which from position 3 to the end of array, then put it in the position 3. So that's the whole idea. So the idea is, first I will select the smallest. I will use loop to do this. Step through position 0 to size -2. Now, since your array size is size, so your array index from 0 to size -1. But if the position from 0 to size -2 are sorted, then size are the smallest one. The position 0 is smallest one, position 1 is second smallest one, go on. Then after the first from 0 to size -2 position are fixed, then the size -1 position is automatically fixed because that position element must be the largest element in the array. So I step through the position 0 to size -2. What I will do, every time find the smallest element, okay, from this position to the end of the array. You first find the smallest element from this position to the end of the array. Then what you will do, you swap this swap it with the element at the position. Your position start from 0 up to size -2. Every time you find the smallest element from this position to the end of the array, you find the smallest one. Then swap it with the element at this position. Now, so this implementation is this. For integer, for example, I say position. I just use position. You can use position from 0, right? Position less than size -1. Position plus. Now, I need to find the smallest element. How do I find the smallest element? I actually use, I don't look at the element, I look at the index. So integer index of the smallest equal position. What that mean? I initially assume ARR position is the smallest. Then how do I ensure he really is smallest, he might not be, right? So how do I update the index of the smallest? I step through the rest of the array, okay? Integer, for example, I say I equal position plus 1, I less than size, I plus plus. I step through the rest of the array. If I found ARR I, this element is less than ARR at the index of smallest, okay? If I find a smaller element, then what I do, I will update index of smallest just equal this I. Now you need to look at this loop. What does this loop do? Each time I assume the smallest element is the element at the position first. So then I step through the rest of the array. If I find one element is smaller than current smallest element, then I update this current smallest element is this element, but I didn't really use the element value, I use his index, okay? After this for loop go on, now after this for loop, index of position of smallest is the index of the smallest element. M1 ARR position to ARR size minus 1. Okay, I found the smallest. Now I need to swap them. So how to swap? In your test, we say how to swap. You say integer temp equal ARR position, right? Then you say ARR position equal ARR index of smallest, then ARR index of smallest equal temp. This is how you swap them, okay? So basically we fulfill what we plan to do. 3 steps. The last loop, outside loop, go through position from 0 to position of size minus 2. Then every time I find the smallest element, start from this position to the end of the array. Then I swap this smallest element with the current the element in the current position. That's called select. Every time I select the smallest one, put in his final position. Okay. Now let us test this project program. So I want test the select sort. Do 2 again. Into 9 integers 1, 8, 4, 3, 6, 2, 5, 7, 9. Okay. Then you say after sort the array is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we really sorted it. Okay. So let me end here. So I leave 2 functions for you to implement by yourself. I hope you got this idea. Insert sort, I believe you can find the algorithm and its implementation in the book's access part. I don't remember if bubble sort is also in the textbook or not. If it's not, it's easy for you to search on internet, okay, to find this bubble sort idea. Then you implement it. If you have any more questions, please give me an email. Okay, see you next time. Goodbye.